Hello friends, today we discuss about how to draw shear force and bending moment diagram. As shown in figure, there is one simply supported beam. Supports are provided at point A and at point B. First step is to find support reaction. So finding support reaction, first draw one simple diagram. In simple diagram, wherever support is provided, mark reaction. So supports are provided at point A. So mark reaction RA and support is provided at point B. So here mark reaction RB. In second step, convert UDL into point load. Point load as it is 10 kN at point C. Between D to B, UDL is acting on the beam. So what is the meaning of UDL? UDL means uniformly distributed load. So per meter length load acting on the beam is 5 kilonewton, so total length is 2 meter. So how much load acting? 5 into 2, so 10 kilonewton load is acting, and this load is acting always its center of gravity, means at its middle point. So 2 meter length, so load acting on the beam at 1 meter, 1 meter. So here distance is 1 meter and here distance is 2 meter. So in simple diagram, wherever support is provided, mark reaction and convert UDL into point load. So this is our first step. In second step, taking moment always from left side support. In our case, left side support provided at point A. So in second step, taking moment at A. So what is the condition? Anti-clockwise moment is equal to clockwise moment. So what is the meaning of a moment? Moment means force multiply perpendicular distance. So we take moment from left side support. So press the thumb here and rotate the finger into the direction of force. So press the thumb here, direction of force 10 kilonewton downward. So here moment goes in clockwise direction. Clear? So in clockwise direction, I return 10 into 1. Clear? Again press the thumb here, left side support, and load is 10 kilonewton. Press the finger, rotate finger to the direction of force. So again this force goes into clockwise direction. So this force goes into clockwise direction. So moment is clockwise, 10 kilonewton force. Perpendicular distance from the left side support is 2 plus 2, 4. So 10 into 4 goes in clockwise direction. So I write 10 into 4. Then again press the thumb at left side support and rotate the finger to the direction of force. So here reaction RB. So this force goes in anti-clockwise direction. So RB and perpendicular distance is 1 plus 2, 3 plus 2, 5. So RB into 5 in the anti-clockwise direction. So in anti-clockwise direction, RB into 5. Make calculation. So 10 multiply 1, 10 plus 40. So 50. So RB into 5 is equal to 50. So RB is equal to 50 by 5. So RB is equal to 10 kilo Newton. So this is our first reaction. In second step is summation of upward force is equal to summation of downward force. So upward force is RA and upward force is RA and RB. So RA plus RB is equal to total load. So total load in our case is 10 kilonewton plus 10 kilonewton. So 10 plus 10. Put the value of RB. So RB is 10 kilonewton. So here 10 kilonewton, 10 plus 10, 20. So RA is equal to 20 minus 10. So RA is equal to 10 kilonewton. Next step is shear force calculation. what is the meaning of shear force? Shear force means algebraic sum of unbalanced vertical forces to the left side or right side of the section. So, what is the meaning of this sign? If we consider this is section, so this is our left side and this is our right side. So, if we start calculation from left side, then upward force plus and downward force minus. And if we start calculation from right side, then downward force plus and upward force minus. In our case, we start calculation from left side, so upward force plus and downward force minus. So we write from left side. So in our example, first left side point is 8A, then C, then D, and last point is B. So we start calculation from left side. So here we write shear force at A, then shear force at C, then shear force at D, then shear force at B. So shear force at A. So we start from left side, then upward force plus and downward force minus. So at point A, there is one reaction. So RA we get 10 kilonewton. So here we write 10 kilonewton and RB also we get 10 kilonewton. So RB is equal to 10 kilonewton. So at A point the reaction goes in upward direction. So here we write plus 10 kilonewton. Then find shear force at C. First we write value of previous shear force. So previous shear force value is plus 10. Then between A to C there is no force, and at point C there is 10 kilonewton force acting downward. Downward means minus, so minus 10. So our answer is 0. Then find value of shear force at point D. So again we write value of previous shear force. So write 0, and there is no force between there is no force between C to D. So again 0. So shear force at D is 0. Then we find value of shear force at B. So first we write value of previous shear force, that is 0, and there is 10 kilonewton force. There is 10 kilonewton force acting between D to B. So minus 10, and at point B there is 10 kilonewton force acting. But in example this force is not considered, but adding this value our answer must be 0. So here answer is minus 10 because we don't consider this last point force, but by add this means this force goes upward means plus 10. So our answer minus 10 plus 10 is equal to 0. Then last shear force value must be 0. Then our calculation is right. In next step we draw shear force diagram. To draw shear force diagram, above this line value should be positive and below this line value should be negative. First we mark whatever shear force we get. So shear force at A. So shear force at A is 10 kilonewton. Shear force at A is 10 kilonewton. So we mark here 10. Then At point C, we get shear force 0. So this is our 0 value. Then shear force at D, again answer is 0. So we make 0. Then shear force at B, the value is minus 10. The value is minus 10. So here below line, so minus 10. Clear? How to draw shear force diagram? If point load acting, if point load acting at point, then draw straight line. If UDL is acting, then draw inclined line. And if no load between points, then also draw straight line. Okay, so at point A, there is a reaction, so draw straight line. So I draw straight line. Between A to C there is no load, so again I draw straight line. At point C there is reaction, so sorry, there is point load, so draw again straight line. Between C to D there is no load, so again draw straight line. Between D to B, between D to B there is UDL. So UDL means inclined line. If we consider last reaction force, then our answer is 0. So here again draw straight line. Clear? Upward positive and downward negative. So this is our shear force diagram. Again I repeat procedure. If point load acting, then there is a straight line. If UDL is acting, then there is inclined line. If no load condition, then there is straight line. At point A there is reaction, so I draw straight line. Between A to C there is no load, so I again draw straight line. At point C there is a point load, then draw straight line. Between C to D there is no load, so I draw straight line. Between D to B there is UDL, so I draw inclined line. And if we consider last reaction force, then our answer is 0. So again I draw here straight line, upward positive and downward negative. So this is our shear force diagram. Next step is bending moment calculation. What is the meaning of bending moment? Bending moment means algebraic sum of moments to the left or right side of the section is called bending moment. What is the meaning of this sign? If we consider this is section, then this is left side and this is right side. So if we take moment from left side, then clockwise plus and anti-clockwise minus. And if we taking moment from right side, then anti-clockwise plus and clockwise minus. So in our case, at point A, we take moment from point A, at point A. So bending moment at point A. So bending moment at point A. So MA. So first hide this point, A point. Then see right side there are 3 force, and left side there are no force. So no force, no distance. So bending moment at point A is 0. So bending moment at point A is 0. Second, take bending moment at point B. So again hide point B point. Hide B point. There are 3 force to the left side, but there are no force to the right side. So no force, no distance. So bending moment is 0. So bending moment at B is equal to 0. Then finding bending moment at C. So again hide this point. Then see, left side only one force and right side there are two force. So taking moment from left side, so left side, so this moment goes in and moment goes to clockwise direction. So clockwise direction taking positive because we consider left side. So 10 kilonewton force, perpendicular distance 1, so moment is 10 into 1. So bending moment at C 10 kilonewton into meter. So bending moment at C 10 multiply 1 is equal to 10 multiply 1 is equal to 10 kilonewton into meter. Then finding bending moment at D. So again hide this point D and C, both side force are equal, we taking moment from left side. So RA multiply perpendicular distance 3 and this moment goes to clockwise direction. So clockwise direction means plus. So RA into perpendicular distance 3. So 10 into 3 and this moment goes in anti-clockwise direction. So minus. So 10 multiply perpendicular distance 2. So 10 into 2 but goes into anti-clockwise direction. So minus. So 10 into 2 minus 20. So bending moment at D is equal to 10 multiply 10 multiply 3 minus 10 multiply 2. So 30 minus 20 is equal to 10 kilonewton into meter. Otherwise you easily you can find moment is either plus or minus. If force is going upward then you take positive, and if force is going downward then take negative. Last 2 point bending moment 0. Then if we finding bending moment at C, then hide C and see which side force are less, and then taking moment from this side. Thank you. Then draw bending moment diagram. In bending moment diagram, first you mark bending moment. At point A, bending moment is 0. At point C, bending moment is 10 kilonewton into meter. At point D, again bending moment is 10 kilonewton into meter. And at point B, bending moment is 0. In bending moment diagram, wherever point load, then draw inclined line, and if UDL is acting between point, then draw curve type. So at point A 0, at point A there is reaction, and at point C there is point low. So between A to C, between A to C inclined line, C between at point C 10 kilonewton into meter, and at point D is 10 kilonewton into meter. So again draw straight line. Then between between D to B there is UDL. So draw curve. So between D to B there is UDL. So draw curve line. So this is our positive bending moment. So this is bending moment diagram. Thank you.